Okay, so find number 1. Other side. Yours should look like mine. It's actually at the bottom. You have 4 problems at the top, 4 tables at the bottom. Find number 1. It's bottom left corner. So we have not wrote rules yet this year. I think you did them last year, but we have not done them this year, so I'm going to take a step back. We have looked at tables before. Nolan, sit up so you'll stop talking to him, please. Someone tell me something that we do know about these tables. Cam?
Like it's a pattern or something.
Okay, there are some patterns. There's actually 3 different patterns on any given table. The inputs have a pattern, the outputs have a pattern, and from the input to the output there's a pattern. So you are correct, there are patterns. Callan? Jack? We're not talking about this specific table. We're talking about what do we know about input-output tables, because we do know a lot. Hurry up. What do we know? When have we seen these lately? Lena? There are patterns, I agree. One of these is an X, one of them is a Y.
Oh.
Which one is which, Nolan?
The X is on the left and the Y is on the right.
Yeah, on this first one, I want us to label that this is our X number and this is our Y column. So all of this side, all of our inputs are X values. All of our Y's are our output values. So really, what could I write from this table? What could I come up with? Kinley?
It's a coordinate plane.
It's not a coordinate plane. I could graph them on a coordinate plane. What do we call those things? What do we call these? What do we call those? Chase?
Charts?
No? Callan?
Ordered pairs.
Ordered pairs. Okay? These are all connected. These are ordered pairs. I can pull the information from an input-output table and place it on a graph. We haven't had to do that. We have pulled ordered pairs from an input-output table, but we haven't had to complete it and then do that. So when we are writing the rule, we are finding the relationship between the input values and the output values. So we have to figure out how can I get from the inputs over to the outputs. So how can I get from 25 to 15? And think about like our math rules, because sometimes there's more than one that works. To get from a larger number to a smaller number, what are my 2 options? Avery? To get from a subtract or to get from large to small? Divide. So if you're going from a large number to a small number, usually you can subtract or divide. Sometimes you can do both. If I'm going from small to big, Cam? Add or multiply. Okay? And again, sometimes it works. 2 different things work for one set. So you have to check both given sets to make sure your rule applies to the whole table. Okay? So Jack, now how do I get from 25 to 15? Subtract 10. I want you guys to write that right there in the center. And there's a reason I want you to write it there in the center. Put the marker away and leave it away, please. Check that rule on the other given information. So here's a full set. It has to work for both. What's 20 minus 10? 40 minus 10. 30. Does it work on both sets of given data? Yes. So my rule is not subtract 10. That's like the 3rd grade rule. We're in 5th grade. Our 5th grade rule, I want you to write this just out here to the side. Write rule. And then I'm going to see if you can figure out where it's coming from. Is x minus 10 equals y. Lena, how did I come up with that?
You take your x coordinate and then you subtract 10 from it, and that's when your y
Yeah, no matter what my x value is, if I subtract 10 from it, it will always give me my y value. So now that I know that, I can just take the x value minus 10. What's 30 minus 10? 20. 35 minus 10? 25. 45 minus 10? 35. Now, so our rule is the x value minus 10 equals our y value. But there are other patterns, like you said, if I'm looking at just my x pattern, what is happening over here, Carter? Not timesing. It's increasing by 5, so it's adding 5 each time on the x coordinates. What about the y coordinates? Cam? It's also adding 5, okay? But those particularly are not important to us right now. We're focused more on the rule. So we are trying to come up with something like that for each of these problems, okay? I could also write this as y equals x minus 10. Why does that one also work, Jack? Yeah, I just put the equal sign in front instead of the back. Still the exact same thing. Let's look over at number 3. I think you got to look to the right, I believe, right?
Yep.
Okay. Skip number 2. Let's go to number 3. Same thing. We're going to label our x's and our y's. Which values are our x values? Paxton?
X, 0, 2, 3, 5, and 6.
Yep, 0, 2, 3, 5, 6. So let's put an x up at the top there. Hold on, I'm frozen. So the outputs are our what values? Y's. Okay, now on this one it actually gives us 3 sets. A set means both of them are filled in, okay? Which set is not really beneficial to me? It's not 0 times 0. The ordered pair 0, 0. Why is it not beneficial? Yeah, zeros just kind of do crazy things. And it should still work with our pattern once we figure it out with our rule, but it's usually not very beneficial to help me figure out a pattern, okay? Later on in 7th grade, it'll be very important because if there's 0, 0 in it, it tells you that it is a proportional relationship, which again, right now doesn't mean anything to you. Goodness. Now okay, I can't write. So look at 3, 9. Jalen, how can I get from a 3 to a 9? You can multiply by 3 or what, Callan? Add 6. So always look for 2 because if 1 doesn't work, you have a second option. So 3 times 3 is 9. 3 plus 6 is 9. Do you guys agree with both of those?
Yes.
So then we have to go to the other set of given information. So I'm looking at the 5 and the 15. 5 plus 6 is what? 11. Is that an 11? No. So what's my rule? Lena? Yeah, it's going to be times 3. And again, I wish I could actually write here. In the center, I want you to write times 3 right here. 3 times 3 equals 9. And then write 5 times 3 equals 15. I'm going to try and close this real quick and see if I can't do.
Frozen, but not
I can't. Oh, there we go. Okay. Now let me. Okay. So we said it's times 3 times 3. I want us to go ahead and write times 3 all the way down because if it works for 2 of them, we just have to assume that it's going to work for all of them. So if that's my rule and if this is x and this is y, who thinks they know my rule? Who thinks they know the rule? Jack? Okay, so x times 3 equals y. Could I write 3 times x equals y? Yeah, same thing. So in the next, let's check our 0. 0 times 3, is that 0?
Yeah.
Okay, so it works. Looking here, this one's a little bit backwards. This is saying, and I want you to write it out here to the side, what number times 3 equals 3? All I did is in place of the x, I put a box because it's something I don't know. Times 3 has to equal my y value, which is 3. Avery? 1. Do you guys all agree that 1 times 3 equals 3?
Yeah.
Okay. Now we can fill in this one because it's written 2 times 3 equals 6. What about the next one? What would I have to use since neither are given? Nolan? Cam?
You would have to find the rule for the x and the y.
Yeah, so we'd have to kind of find the patterns of the inputs, the patterns of the outputs. Let's skip it for now. Let's go down here. 6 times 3 is 18. Now we should easily be able to find those. 0, 1, 2, 3, blank, 5, 6. 4. And then what's 4 times 3? 12. Let's check and make sure that side makes sense. 0, 3, 6, 9, 12, 15, 18. Stella.
I also noticed that the output side was counting by 3.
Yep, so the output side is also counting by 3s. Yep. Now, if it wanted me to graph those, who can give me one ordered pair that would be on my graph? Cam? What?
4, 12.
Okay, 4, 12, I'm going to start at the top. 0, 0, who can give me another one? 1, 3, 2, 6, 3, 9. Everybody see where I'm coming up with those ordered pairs? Okay. I want you to take a second and try number 1 and 4. Try number 1 and 4. I want you to come up with the rule. Or sorry, 2 and 4. Come up with the rule, so the y equals thing, and get the boxes filled in. So try and come up with the rule and fill in the boxes. So Carter, you're trying to do number 2 and number 4. If you get those two done, I want you to go to number 6. So 2, 4, 6. Okay, is someone in here reading this book?
Great.
Okay. Someone left it. Carter, do you have 2, 4, and 6 done? Well, why don't you pick up your pencil and put your clipboard down? It's easier to write when it's not up in the air. Okay, Logan, let's everybody go back to number 2. Logan, what did you do on number 2? Okay, because how else can I get from 2 to 14? By 7. Yeah, so you can add 12 or multiply by 7, but if I go down here to the 8, what's 8 times 7? 56, and I'm trying to get to 20. So that tells me it has to be the plus 12, because is 8 plus 12 20? Yes, 8 plus 12 is 20. So what is my rule, Lena? What rule did you write? Okay, good job. So what is paired with 4, Jalen? 16, yep. What's paired with 6, Callan? 18. Now, for the last one, raise your hand if you put 10 and 22. Okay, 10 and 22 would be the next entry, and that's fine. But I could also put 30 and 42. Why does that work also? Because does it meet my rule or fit my rule? Yeah, so that's why I don't want you to focus too much on the patterns on the X and the Y, because especially the older you get, like they could skip. They could leave out that set right there. Okay, they could leave out 6 and 18, and the table is still correct as long as every set matches the rule. Okay, so if you had 10 and 30 or 10 and 22, that's a perfectly okay answer. Sometimes it will give you the rule and just say, what are 3 sets that could work? Why is that harder? Jack? Yeah, that just means you get to make up any X values and then find the Y values. If it says name 3 that would work, you get to just pick any X value, add 12 to it to find the Y values. Those ones are a little bit trickier because you don't feel like you have enough information, but it's really, it works for any set of numbers. Okay, number 4. What is my rule for 4? Emmett, what did you come up with?
-4.
So that's not a rule. That's part of it. What minus 4? So X minus 4, what's the rest of it? Equals Y. Good job. So this one would have been 19, 30, 52, 63, 74. Okay, number 6. Number 6. Nolan, what'd you come up with?
X divided by 2 equals Y.
Okay, X divided by 2 equals Y is correct. Who can tell me a different way I could write that? Kanan? Minus 12 only works here because it's 48 minus 12, 24. So I do agree that minus 12 works here, but it doesn't work there. So that means it can't be my rule. How else can I write X divided by 2 equals Y? Briley? I'm wanting the rule. We know what it is. I just want to know a different way I could write it. Kinley?
Y times 2.
Nope. Anytime we're writing the rule, it has to be equals Y. Naomi?
Y equals X times 2.
Oh, X divided by 2. So we could write it like that. I want you to write all of these for this one. One more way. Avery?
Y equals 2 divided by X.
Nope, you can't flip-flop the order on division. On multiplication and addition, you can. That's why we're doing this, because we're practicing. Stella?
X minus...
Nope.
Oh, wait. Hold on.
I'm trying to write x divided by 2 a different way. How else can I write x divided by 2, Reese?
2 divided by
Nope, we can't flip the order. Cam?
y divided by 2 equals x.
Nope, we can't switch the numbers. Ethan?
X over y is
Not x over y.
oh,
X over, because y equals x divided by 2. Does that say x divided by 2?
yes.
Yes, I'm showing you that because sometimes if they give you the rule, they give us a division problem as a fraction. Should we know that x over 2 is whatever x is divided by 2? Okay, so let's fill this one in. 28 divided by 2 is 14. 32 divided by 2 is 16. That one's blank. This is saying what number divided by 2 equals 20? Jack? 40. That's blank, and then that one works. So this one, if we're following the pattern, 24, 28, 32, 36, that would be 18, 44, 22. Jack? How? Not 1/10, 1/2 would be correct, yep. X times 1/2 is also the same thing. Lena? Can you wait just like a minute till class is over? Okay. Okay, flip it over to the back really, really quickly. What is different here? Last one we're doing. Callan, what is different here? It's sideways. The top is still the x value. The bottom is the y. Paxton, how do I get from 2 to 7? Plus 5. Now, I will tell you, sometimes it's multi-step. Like it might be times 2 plus 1. Does that work here? Times 2 plus 1. What's 2 times 2?
4.
Plus 1.
5.
Check the next one. 4 times 2 is
8.
plus 1.
9.
Does it work?
Yes.
Does it work on the third one? It works on the first and the second. 11 times 2 plus 1. Doesn't work there, okay? But to write that, because again, I'm just exposing you, because sometimes that might be the rule where you're like, oh, you multiply it by 2 and then add 1. That would look like 2 times x plus 1. Because you would take 2 times the value of x and then add 1, but that doesn't work here. So our rule, and if we write it like this, is y equals x plus 3. You would do the exact same thing, it's just the table is sideways instead of vertical. Okay, are you experts on these? No, and today's the last day we're doing this for now. Okay, you'll do a ton of tables in 7th and 8th grade. Sorry, plus 5. Sorry, that should be a 5. Okay, your only homework tonight is to make sure your weekly worksheet Monday is done tomorrow. Okay?